Here's problem number 37 from section 8.4. This problem has a little bit of a trick to it. I'm going to do this as a substitution problem, and I'm going to make u is equal to the square root of s. If that's true, by the way, instead of just taking the square root, the derivative of both sides, I could also say that u squared is equal to s. Now what does that give me? Well, it gives me the ability to change the 1 plus s to a 1 plus u squared. It also allows me to take the square root of s and change that into a u. Now let me take the derivative of this, and what I end up getting is 2u du is equal to ds. So every place I see a ds, I can replace it with 2u du. That u and that u cancel. By the way, when s is equal to 0, u is equal to 0, and when s is equal to infinity, oh, I'm sorry, I have to do an intermediate step first. The limit as b approaches infinity of 0 to b of ds over 1 plus s times the square root of s. And then I'll do the switch step, the limit as b approaches infinity of from 0 to the square root of b multiplied by what did we have over there? 2 over 1 plus u squared du. Finishing up this step, pull the 2 all the way out. The square root, or the 1 over 1 plus u, you may recognize as the inverse tangent of u as evaluated from u to the square root of b, or 2 times the limit as b approaches infinity of the inverse tangent of the square root of b minus the inverse tangent of 0. This is 2 times inverse tangent as b as square root of b approaches infinity. That approaches pi over 2, and the inverse tangent of 0 is 0. And so we end up getting that this ends up being a convergent integral, and it converges to pi.